So we left off, we were solving this particular question using algebra. We talked about using two different points to find a slope. The important thing when picking those points is that you don't pick an outlier, some point that's not following a pattern. And it's also important that you pick 2 points that are a good distance away from each other. Okay, because again, if you pick two points that are close together, you won't get something that's representative of the full graph. All right, so those two conditions you have to look out for. Once you have those 2 points, we solve for the slope using the equation y2 minus y1 over x2 minus x1. Once we have the slope, we're going to plug in either of the 2 points to solve for b. Okay, once we solve for b, we have the equation of the line. So this is the equation of the best fit line. Okay, it is an equation between 2 points on this graph, but it's also representative of the relation. Okay, if we see a pattern there. All right. So, question says, is there only one line of best fit? Who wants to try and answer that? Santos, what do you think? Yes. Okay, Santos says yes. Does anyone agree with him? Disagree? Yeah?
I think because you want to do one combination of 2 points to use.
Yeah, so the answer is actually no. Okay, there's several reasons. One reason is when I'm using a ruler and I'm drawing this, okay, it's quite possible that, you know, I might draw it like this, but someone else might draw it like that. Okay, ever so slightly, but still different. Okay, so it is possible that there are different lines of best fit. Okay, likewise, I could choose 2 different points from the table. Okay, that is still representative of the data, but not the exact same points. Okay, so again, it would give you a different line. Okay, do you understand that, Michael? All right, so it's not always one line of best fit. There could be several different ones. But the important fact is that they're very similar. Okay, they're in the same range of each other. So you should get similar answers. But again, all of these answers and everything that we're doing today is in the area of estimation. Okay, we're estimating. Okay. Definition of a line of best fit. It's a line that best describes the relationship between 2 variables in a scatter plot. It's important to also note, I'm going to add under here, so you want to have a balance of points on either side. And then I'm going to put in brackets here, ignoring large outliers. Okay? All right. Next question. Which strategy is more accurate and why? Yeah, Matthew.
The graph?
Okay, why?
Because then you can see where the point is exactly located.
Okay. I would kind of tend to agree with you in this particular case. You would kind of argue that the graph is more accurate. And the reason why is because you're actually considering all the points. Okay, when you draw this line, you're actually considering all the points. When you do algebra, you're actually just considering 2 points. So unless those 2 points are, you know, right in the middle, they're not necessarily, you know, directly representative of that line of best fit. So in that case, I would kind of argue that you're right. The area where it gets a little bit, you know, dicey is that you're kind of running back and then sort of estimating this area. And also, if your graph's not very accurate or not drawn well, like mine isn't, then you wouldn't get accurate results at all. So if your graph is drawn perfectly accurately and very, very neat, I would argue that you're right. The graph is a little bit more accurate. No one?
Yeah, that's what I was going to argue. Is this, like when you did it algebraically, you got like an exact answer, but because your graph wasn't like very accurate, you got like around 100%.
Yeah, exactly. But I wouldn't necessarily, you know, attribute that to the method. That's just more just me not being accurate on the board. If you are graphing, of course, you're going to use a ruler. You're going to use graph paper, and that error, so to speak, wouldn't be would be much, much smaller, be limited to a very small area of the graph. Okay? So yeah, definitely if you're going to use a graph method, you want to make sure you graph it as accurately as possible. Okay? All right, so example number 2. We're given a month and we're given income for a particular business. So we're looking over a range of 10 months and we get incomes for each one of those months. So right away, what you guys should get in the pattern of doing now is kind of just looking at it and recognizing a pattern. Just looking at the table. Okay, that's important that you do that. That's the first step. So we can see here that as the month increases, we can see that the income is increasing. Okay? Anybody can identify an outlier? Rosati. Which month would you say is the outlier?
Number 2.
No, it's still following the pattern. It's going up, right? It might not be going up as fast as the other points, but it definitely doesn't seem to be still following the pattern. Number 8. Yeah, if we look at number 8 here, we see that everything has gone up. 25, 45, 55, 80, 90, 110, and then all of a sudden it goes down. Okay, and then it jumps back up to 135. So you can see in month 8 there was maybe an issue at the particular store. They didn't sell as much as they would have liked, or whatever the condition was. That's a bit of an outlier. So if you are going to use the algebraic method, you wouldn't want to choose that point. Okay? Any questions about that? All right. So moving on, we use the same method here. First one is using a scatter plot. We make the graph. Once we have the graph, again, a lot more accurately than I have here on the board, but you're going to draw a line with balancing the points on either side. So that's your line of best fit. All right? Once you've done that, you've created that line, you can try and answer some questions. So if this question says, when will income reach $200 for a month? So we're looking at our income here. If this is 160, we're going up by tens. The 200's up here. You're going to run it across, find the value, then run it down and find the month. So we would estimate this would be our value. Okay? This process of extending a graph, where I'm extending this graph to find out an answer, a predicted answer, it's called extrapolating. You need to know this. Extrapolating. Okay, I'm extending the graph, I'm adding extra onto the graph, so it's called extrapolating. If I'm trying to estimate a value within the graph, so for instance, say I wanted to find the value of the month, the middle of the 3rd month, so 3.5. So 1, 2, 3. I don't have a data point, I only have a data point at 3 months and 4 months, but I want to know what's happening at 3 months and 2 weeks. So I'm looking at this point now. I'm trying to determine, this is my 3.5 months. I want to determine the income at 3.5 months. I run this back to there. This is called interpolating. So it's the same word, just the beginning is different. Inter means between, extra means, beyond. All right, so extrapolating, interpolating. Okay, those are 2 definitions you should be familiar with. One I forgot to mention, a definition you need to know, is called a trend. It's a relationship between 2 variables for which the independent variable is time. So basically a trend is like a line of best fit where the independent variable is time. So if we have time on the x-axis and we have some sort of relationship, you call this a trend. Okay? And it's called a trend because it changes with time. That's a trend. Yeah?
On the test, can we choose which strategy we want to use?
It depends. You might be able to choose if I don't specify, or I might ask you specifically to use graphing or use algebra. Yeah.
The interpolating and extrapolating, would that be a possible communication question?
Sure. Yes. All right. So here we use the scatter plot. We interpolated to find this point. We extrapolated to find this point. Now, if I wanted to find either of these points, I could also use algebra. When I use algebra, I'm careful not to choose the outlier, which was month 8, but I choose any other 2 points. So in this particular case, I'm choosing 90 and 20, so I decided to use this point and this point. Somebody asked me before the break whether or not the first point could be an outlier. I think it was Nicholas. It could be. Okay, the first point definitely could, so you can't guarantee you that the first point is going to be accurate. All right, but if it does seem to follow a pattern, in which case it does here, you could also use the first point. Once we have those 2 points, we find the slope, which is 14. Once I have the slope, I plug in either of those 2 points to find out what the value of b is. Then I have my equation for the line. So this is the equation of the best fit line. This is my equation of the best fit line. Once I have that, now I can use this to estimate any value. So it's asking me, when will the income reach $200? Well, I take that $200 and I sub that in for y. And I solve for x, because x is my time or my month, and y is my income. Okay, so I sub in 200 here, and then I solve for x, so I get 13.86. Right, which is pretty close to what I have on the graph, right? This is 10, 11, 12, 13. So right around 13. Again, not the most accurate graph, but you get the idea. Any questions with that one? All right, so finally in summary, you can use line of best fit to make predictions using interpolating and extrapolating. Again, inter is between, extra is beyond. Predictions can be made from graph using algebra. So hit 2 points, not too close together, not too close together, and not outliers. When drawing a line of best fit, the points should be balanced on either side, so that's making sure there's the same amount of points on either side of the line, and you can use 2 points to determine its slope and equation. And again, you want to make sure you use those points. Any questions? All right, that's the end of the lesson.